Hello again, everyone, and welcome back to Enterprise Linux Security. We're up to episode number 4, and we're going to talk about the supply chain today, as well as a little bit of buzzword bingo.
Yeah. Hello, Jay. Hi, everybody.
How are you?
All good, Jay. Thanks for having me again. And yeah, like I said, today is buzzword bingo. So if you're listening and you have a sheet of paper where you can write it down, please pay attention. It's going to be crowded today.
Yep, lots of acronyms going on in today's podcast. The thing is, we love our software when it works, right? And, it could not work for many, many reasons. But if there's a security issue in the software we download that we didn't know was there, that's a big problem, especially in the enterprise, because, bad guys just love to get their code in things. And the supply chain, when it comes to software, is no exception.
Exactly. And when you see a new CVE, it doesn't say it affects this application and that application and all the others. The list is not exhaustive. It might say it affects libcurl, for example, and I keep falling back on libcurl because it's everywhere. And a specific software that you use might not mention that it uses it, and in fact, it pulls that library. So you might be vulnerable without knowing. And that's part of the supply chain that we'll be talking about today.
And another thing that I think factors into this is just all the different ways we can get software. We can compile it ourselves. We can install it via a repository, an app store of sorts, a Docker container. There's all kinds of ways to get software on our systems. And my experience has been in the enterprise that everyone is spread so thin, so it's really hard enough. And it's the case that I just grab a container and run it. I just grab a PPA repository, install it, and be done with it. And any one of these things, and it's happened, even Docker containers can have something in there that you don't know is there, that maybe you just installed a crypto locking thing or a crypto miner or something, or malware. And next thing you know, your CPU is running at nearly 100% and you're not even doing any work yet.
And honestly, who goes and checks all the dependencies on the software they install?
Right. And that would be a full-time job, actually beyond a full-time job if you're on every package that your company installs.
Beyond full-time.
Beyond.
But yeah, so let's start with the buzzwords. So first on the list, and going through the supply chain, Google has this nice framework called SLSA. It's written SLSA, and it's pronounced salsa for some weird reason. And it's something that evolved from something that Google uses internally called binary authorization for Borg. And I'm sure some engineer is giggling right now because they got us to say that out loud.
Yeah.
But yeah, it's a framework that stipulates a series of guidelines on how the whole process from source code to final binary should happen, and the steps that should be involved, and what security measures should be in place at each of those steps. Okay, basically, and just to provide this early overview, the supply chain that we are mentioning here is the whole process that goes from writing the code to getting the final binary that you can download somewhere and run on your computer. And it involves a lot of things. It involves getting the commits from the developers into your repository. It involves the build scripts that takes that code and produces the binary. It involves the libraries that get pulled. There are lots of moving parts here that can be targeted for a supply chain attack. And we'll go into each of those and see how you can attack one or more of them.
Yeah, and to put it into even more perspective for people that are kind of new to the world of how software is created, if I'm a developer and I'm creating an application, for example, that, I don't know, plays audio, maybe it has an alert sound or something, I'm not going to want to develop a library or code myself to play sound. Someone else has already done that. So I could pull in a library that allows the sound card to get accessed and then just play the WAV file or the MP3 file. And if I want to add, and this is especially important, security, of course you should add security, but if you're adding in security to your app, you don't want to develop your own security libraries because
absolutely.
you're just asking for trouble. So you're going to pull that into it. And maybe you want you have to show a logo on your app or whatever, a ping image, for example. You have to pull something in to show that ping image. Next thing you know, your app is just this Frankenstein of all these different components that other people have written. So if any one of those components has something bad in it, and I'm not auditing the code, then I've unknowingly developed an app for my company that has something bad in there, and then everyone else suffers. So that's kind of the problem that I think we're dealing with now.
Just the past couple of days, something came up, a vulnerability on Ghostscript that got everybody freaked out because it was possible to pass a maliciously crafted SVG file to Ghostscript and get it to crash and to give you root access when it crashed. So, yeah. And you can exploit that remotely because Ghostscript is everywhere because of image magic. And even less, the less command line tool, it pulls Ghostscript. So you could attack it through less, which is, again, is on every single distribution out there. It's a common tool.
They're so clever.
And
oh boy.
Yeah, it blew my mind when I realized that less was pulling Ghostscript. Why in the world was it pulling Ghostscript? But it was. It includes Ghostscript as a dependency. So yeah, Ghostscript got owned. So did everything else that pulled it in.
It's amazing that some people out there thought security problems would slow down when ActiveX went away, but it didn't.
Yeah.
It used to be all we ever talked about was ActiveX, and then now it's all these new things. But that's so true. It's just such a huge problem.
Yeah. Okay, so I guess we can start with the first point in the supply chain, which is basically bad commits that are included in the code base. And not so that long ago, we actually talked about this, not on the podcast, but on another video, about these researchers from the University of Minnesota that submitted some malicious commits to the Linux kernel and got them in, and they were accepted. And this caused all kinds of issues. People got mad that their time was being wasted looking at this code, and lots of drama ensued. But it basically showed that it was actually possible to create bad code and introduce it knowingly. Right. And they were security researchers. And I'm going to do these air quotes here on researchers.
Absolutely.
Because I'm very mean.
Air quotes. Yeah, they only, in my opinion, proved that human error exists, and we already knew that. So there's no surprise here. I mean, if humans are involved, I mean, I could argue chaos theory when computers are involved, but I won't get into that. When humans are involved, you're going to mess up something. There's going to be a typo. You're going to accept something. I mean, it just happens. So it's like this study that was done that had no value, in my opinion, to anyone, because it was just like not even done with the normal scientific research process that would have absolutely helped it. But yeah.
Absolutely. And the way that it got into a project that has so many eyeballs like the Linux kernel proves that it's more than possible to do that.
Right.
And this framework, this SLSA framework, it has some guidelines on how to prevent that. They have some suggestions on how code review should be done by more than one person. It should never be just one looking at the code. But even they admit that even that will probably not catch all the cases where this happens. So the first of the possible attacks, it's this one. It's submitting bad code and getting it accepted into the repositories.
I think it's important to understand that bad code can be negligence, or it could basically be on purpose, or it could be accidental. It could be something that an individual submitted this code and they had the best of intentions. They were probably proud of their work. And then there's just something like a buffer overflow or something that can happen within their code that wasn't caught. So University of Minnesota was, they did that on purpose. It was knowingly submitting bad code. They knew it was bad. They wanted to see if it was going to get detected. And, there's also going to be, I mean, you could probably argue that most of these hacks that we see are because of a flaw in the code that someone didn't catch that they probably could have caught. And here we are.
Yeah, absolutely. We're looking at this from the malicious angle. This type of attack is when you knowingly and intentionally commit bad code or intentionally flawed code to the code repository and just want to get it accepted there. And after it gets accepted, it will then be compiled and turned into the binary, and the final product will have it there. So attacking the code is the first point. It's the first step on attacking the supply chain.
Yep. And it's also important to keep in mind that it's not just one app. If someone targets a piece of the supply chain that is used in many other apps, or they get it into the Linux kernel itself, which is used on everything from smart TVs, smartphones, Linux servers, you name it. I mean, we're not talking about one app that's on the news. We're talking about like multiple things. It could be very widespread. And I think that's the best thing about shared libraries is you don't have to rewrite the code. And that's also the worst thing too, because are you looking at the code? Probably
exactly. Not. Probably the ones that are looking at the code are the ones you don't want them to. But
yeah.
But yeah, this gets recursive. If you pull libraries, the libraries can have exactly the same issues as your own application. If the libraries were attacked on their own libraries that they pull in, because they will. Strictly speaking, very little code today is completely original. You always rely on somebody else's work. You always rely on something that has already been invented and tested and tried and works. But most of the time you don't actually go into and look at all the code that created it. So bad code could lie there. And then you'll pull it into your product, and then that gets pulled into another, and then this cascades out. But moving on, if you cannot submit a bad code, maybe you can compromise the code repository itself. Maybe you know that the company is hosting a Git repository on their own servers, and you somehow get access to that code repository. Then you can change the code that is there, and no one will probably notice until it's too late. If you have control of a Git repository, you can simulate a commit from some other user that is well known in the community, and no one will look twice at that commit. Oh, it was by so-and-so, and he's a good developer. Let's accept it and move on.
Yeah, and it matches the API key. What's the problem? I mean, the API key might have leaked to someone who shouldn't have that API key, but they see it matching a user's name and API key, and all that lines up.
If you have the server, you don't even need the API key. You just go in there and change the files. You have the server. And one prime example of this, and Google mentions this on their post as well, is PHP. PHP used to be hosted on their own server, and earlier this year, on March, it got pwned. So somebody made 2 commits into the code base that someone gladly caught and didn't actually let it escape into production, but they were there and somebody had on the server. So the result was that they decided to move to GitHub. And just as an aside, GitHub is a great service, and sometimes things happen even to great services. No one expected GitHub to fail a few weeks ago, and it did. So pay attention. It's not foolproof.
Yep. Nothing is.
Yeah, unfortunately.
If everything was perfect, we wouldn't even be talking right now.
Or probably not having a job.
That's true.
Okay, so you missed the code submission. You couldn't get in. You couldn't compromise the source control platform. So the next one, you somehow managed to affect the build scripts. Okay, so you don't necessarily affect the code that is in, but you affect the scripts that get called before the code is compiled. That may involve something as trivial as pulling a malicious file from some other third-party server and including it without the developers knowing about it. Because those scripts will be run with full privileges to the code and with full privileges to the compiler, so it's very easy to add a flag or to add a new include there. And that's yet another way of compromising the supply chain.
Yeah, especially when it comes to like CI/CD and getting into one of those when it's building the software.
Absolutely.
That keep your Jenkins server safe, please.
Yeah. And Jenkins again, just last week, new exploits on Jenkins, and Jenkins everywhere was vulnerable.
There's a reason why mine is on an island. I have a Jenkins server with nodes, and you cannot get to them from the outside. I have to go through a bunch of hoops to get to them myself.
Yeah, just pull the plug, man. It's
just put the
at
server
some point.
Unplug everything. Just, put it in the closet.
At some point, people would just pack up and leave. It's so many vulnerabilities. Everything is just leaking everywhere, and just people just, I quit.
It's almost like a
But
boat that has a bunch of holes in it, and everyone is just patching the holes and trying to get to the other coast.
yeah, but the boat is actually rusty and it's creating new holes all the time.
Yep.
Okay, so we went through the code, we went through the code repository, the build scripts. Now the next step is the actual build infrastructure, the actual servers where the build is done, where the compilation happens. You can attack the supply chain through those servers. Say, for example, you change GCC that's running on that server for your own version that has some special changes that you made to it. And that's yet another way of you attacking the supply chain. So the binary that gets produced, it has all the right code, it has all the right libraries, it uses the right scripts, but it gets compiled with the wrong compiler, with the one that you control. And then you produce the outcome. So the binary file will do whatever you tell him to do.
That scares me a lot.
All of this should.
Yeah, it really does.
All of these actually should.
Yeah, it's just something about it being compiled, and it's just everyone at the company is trying it out on their computer. Oh, it looks great. It has all the right stuff there. It's doing the thing it's supposed to do. It's fast. Let's ship it right now. Oops.
Or say, for example, it's the new access control application that was developed in-house and is built completely on your servers. And now it's just leaking the credentials somewhere else, because they go through it and it has full access to the credentials and it leaks it out. Yeah, this type of attacks, this is scary. And really, we need to move a bit off script here. If you consider the web browser that you use, the web browser pulls libraries for everything from PGP to email, because it handles all the protocols, for FTP because you can open FTP sites with it, for displaying images like you mentioned before on your screen, for video, the video codecs itself, for audio, for video conferencing, for all kinds of things, for window management. All those libraries, they get pulled into at compile time. Any one of those could be compromised. Any one of those could leak your information or could access your system in a way that you don't want it to. And no one checks, because it's not humanly possible to actually check it. No one would go through all the code to see if everything is right or not. We just trust the developers and that they have secured their servers where they build it.
Yeah, I never would have imagined when I started that web browsers would be used as heavily as they are now, because it's like when I started, the only time I ever opened a web browser was to read an article or download a file or something. I was checking email through an email client. I had an instant messaging client that was separate. Everything was separate. The browser was just for some very specific things, and I kind of missed that, to be honest.
My first web browser, and I'm dating myself here, was Lynx, a text-based web browser.
I love that browser. Yeah. Lynx and
Lynx. Even that, 20 odd years ago, that pulled the lip curses. And to have the display on screen and get the text in the right place and get the text fields where you needed to fill content, that pulled the libraries to do that. So even if Lynx itself was not exploitable to something, any of the libraries that it pulled could be. And even at that time, 20 odd years ago, it would have lots of libraries pulled in to do protocol negotiation, to do text editing, to do text display, to do scrolling, lots of things that it pulled into libraries. So because then again, like I mentioned before, this gets recursive. Any of those libraries could be attacked in any of these ways that we are mentioning right now, or any of the libraries that those ones would pull in could be attacked in these ways, and you would never know. You can have that Bitcoin miner running right now and not even realizing it, simply because it was well crafted and it's not using 100% of your CPU, just 4 or 5%. You won't notice it, and it's creating coins somewhere else.
I've run into that. I've seen a server that had one of those on there, and it was running the CPU at like, I want to say it was like 49%. It wasn't 50%, which, a lot of these Nagios and Zabbix monitoring servers are going to trigger when it gets to a certain point. But we always expect our servers to be doing work. So sometimes if I see a server that's like almost 0% utilized, that means something crashed, because that server is supposed to be doing something. It's supposed to be running something, but it's also not supposed to be at 100% either. So, floating around 40, 50% or lower, yeah, you're right. It totally flies under the radar. And I don't remember how we noticed it. We noticed it really quickly, but it was because of something else that it did, not because of the CPU usage.
And there is a pretty good incentive to be creative on those types of things. So people will spend the time and the effort to create them properly.
The name of the process was very close to the name of an actual process that you're supposed to be running. And I remember Googling this. I'm like, I think a letter's off here. This isn't spelled exactly the way it should be spelled. There's something up with this thing. It needs to get off the system.
Yeah. Make a note of that comment there, because the last step on the supply chain attack, it actually deals with the names of packages. But we'll get there in a moment.
Yep.
Okay, so we've been through all these steps. The next one is if you have some way of uploading some file after the binary is created, but you have a way to include the file on the final package, because let's face it, an application is hardly ever just the binary file. It has some other accompanying files that go along with it. The service description, it can be the cron job, it can be some type of configuration file. If it's in your hand to be able to add something to the final package, that's also a vector for a potential attack on the supply chain. And say, for example, Google has the example of CodeCov. It's a tool that's used to check code coverage, something like SonarQube. And it was exploited in a way that let an attacker add files at the end of the build process, like continuous integration, continuous development, and then it added something extra to the output.
Lovely.
It's always fancy. The next one is actually something that affected Node.js some time ago, which was malicious packages being accepted into mirrors. I can't recall the exact date. It was around a month and a half ago. Some 10 or more packages were found to contain droppers for Bitcoin miners or some other cryptocurrency. But they were accepted. They were the actual libraries, the ones that you actually wanted to use. And they had thousands of downloads because people used them and included them on their projects. And in the background, they had been tampered with, so they would also deploy crypto miners wherever they were used. And this is yet another attack on the supply chain. You're not expecting your Node.js packages to contain these extra bonuses.
They're extra features. Come on.
Yeah, they're special features.
Special. Yeah. Oh gosh, it's horrible.
Yeah, and going back to what you were mentioning before about the package name, the process name being very similar, that's the last example that we have here for supply chain attacks, is when you have packages or libraries or applications that you're going to include that have a name that's actually very, very similar to what you're looking for, and you include it by mistake. Okay, that works into the lack of attention of the developer or someone looking at the compilation step not to notice that, but that's yet another way. And if you look at, say, Android's App Store, 99% of those applications are trying to be some other application that's very famous, and they are trying to get people to download them by mistake, thinking that they are getting the original. And that's just yet another example of this. So it's not just the process that has a similar name, but the whole package. So you include the package, you're expecting it to do something that you need on your program, and then it doesn't.
Yep. I've seen that on app stores before. I mean, in my case, I don't really use mobile devices for productivity reasons personally, but I remember looking at a game. I was just looking for one, and I didn't install it because I knew it was fake. But I'm just thinking, like, you have a parent out there just downloading apps for their kids or something. And well, the character has a red hat and it has the word plumber in it. So it must be the same thing. And then next thing you know, there's all kinds of things going on their phone. Their phone is slowed down and is barely usable.
Yeah, because that's the environment we're in. So
if it's an enterprise app, if it's Slacky instead of Slack or something. I don't know. I'm just making up stuff. Don't take that idea and use it. Please don't be evil with that. It has a similar icon, and it's a messaging client. Must be the one my company needs me to install. What do you mean it's giving all of our information to a third party?
Absolutely. And it could be something as smart as showing you a similar interface and sending the commands to the actual application in the background so that you get the right feedback, but then also sending a copy of those data somewhere else, of the credentials or the things that you type in there, and those can be sent somewhere else. And okay, going through all the steps and seeing the different ways that the supply chain can be attacked, let's look at some of the mitigations that can happen here.
Yeah, what can we do
this SLSA framework that Google developed with this funny name, it's a set of guidelines that cover each of the steps that we mentioned that can be attacked. Basically, it's security requirements on the code repository. It's ways that your scripts need to be vetted before they get included in the build script. It's the way that your compilers need to be checked, the way that the servers where the compilation happens need to be protected. It's a series of guidelines to make sure that whatever you tell him to create is what you actually get on the other end of the pipeline. If you have the code to create, say, an uncompressor, something like nzip or something like that, you're going to get something on the other end that does exactly that and just that, and you don't get any special features that you're not expecting there. And this is a series of guidelines that you should follow when you're serious into software development, and it really helps to protect everything. And in addition to this SLSA sync, to this SLSA framework, just this week we got the news that a new ISO standard was out. And see, here is another acronym for the bingo. There is a new ISO standard for SPDX. SPDX is Software Package Data Exchange. It's basically a software bill of materials. A bill of materials is the list of all the components that go into creating something. For example, the bill of materials for a laptop would include all the wires, all the cables, all the wires and all the cables, all the cables that go into it, all the screws that go into, all the capacitors, all the discrete components that go into the plastics, the shape of the plastics. It would be pages and pages long. But nothing like this existed for software. So whenever a new vulnerability came out and the text of the description of the vulnerability said, this affects library so-and-so, you had no way of knowing if that was the only thing that it affected or not. You were trusting whoever created that description to be accurate and to be true. Okay, and it might not be. That person might not know that that specific library was also being used somewhere else by a third party or something. Having this bill of material accompanying a package gives you the ability of, through some tooling, actually checking if this package is using that library or not. And expanding on this, you could actually check all the packages on your system to see if they included that specific library that you know is vulnerable, so that you could identify whatever needed to be patched on the system. And having this as a standard has the added benefit of creating this goal that all the companies that deal in security and development, that they can strive to achieve. Without having this standard, each company might have their own initiatives to get code security, but it wouldn't work with whoever developed the libraries that they're using, or the third-party tools that they're using, or the compiler that they're using. And this provides a unified view of all of this. This is really important. This is, I don't want to say historic because it's not, but this is really, really important stuff that happened on the security landscape. And if this actually gets adopted widely, this could lead to better information, less exploits being available, more insight into what you are running on your systems, which is something that open source advocates are always talking about. You know what you're running. You know what you want to be running. You had no way of knowing if that was exactly what was actually running on the system or not.
Right.
This is a step in the right direction. This will give you more information about that, and more information is always good. More transparency.
Absolutely. Then there's some examples that they have available too in the repository for the bill of materials, and Since it's now an ISO standard, I'm sure that's going to mean that the adoption is going to be better, and then it'll be more popular and actually used. SLSA is pretty good. There's 4 levels, as I understand it, of, level 4 being the best you can get. Level 1, it's good, but not the best. Different ways of looking at the same thing. But, with the SPDX, I really like what I'm seeing so far, and I really hope it gets to be more widespread.
Yeah, and the thing is, SPDX is that bill of materials, that software bill of materials, basically. And SLSA is the guidelines that help you first ensure that the bill of materials is correct and give you a way of creating that bill of materials in the first place. It's a set of tools that Google has already in place. Mm-hmm. But more than that, this is a change in philosophy, in the way you approach software development from a security standpoint. It might, at the start, create some higher barrier of entry for new developers wanting to contribute to open source projects, because it's another thing that they need to consider when they are committing code. Oh, am I following the guidelines? Is the commit right? And all that. So it might scare away some people, but in the end result will be of higher quality.
Right.
And you need to recognize that having security concerns at this point in time, it's really important. It's not something that you can just tack on after the fact. It's not something that you need to worry about only after your app has shipped or something like that. You need to start looking at security concerns from the get-go. And the sooner this gets adopted in the project lifetime, the better.
Yep, it's great. Yeah, it's very important for developers to understand this. Also, the individuals doing the code reviews as well need to understand this, especially because they're the ones that are going to be the gatekeepers. Okay, great code, but you need to, follow this guideline here. You missed this one. Hopefully, that'll certainly help it not get out the door with some of these problems. But it's definitely important that everyone's on the same team with this and understand what's required at their level of responsibility in the process and help make that happen.
Absolutely. And before we started recording, you mentioned something that's also important, and it's also mentioned on the SLSA list, which was reproducible builds. You mentioned BSD is having this already, or at least an effort in this direction. So reproducible build is a way of describing the build process completely in a way that something that I build on my machine here with my tools and my libraries that are installed on my distribution will create exactly the same binary if those steps are repeated on your machine, for example.
Right.
And while this seems pretty basic and obvious, it's not. If you try to do this experiment at home, if you have 2 different systems, say a Fedora and you have an Ubuntu, and you compile the exact same hello world code on both of them, chances are pretty good that you'll have 2 different binary files, and you shouldn't. It's the same code, you should get exactly the same result. And this has been a struggle for many years, especially for distribution maintainers, because recreating the build environment is not trivial. It's not something that's easily achievable.
Right.
But making sure that you get the exact same binaries also helps with security, because it means that at any point, if you don't trust the binary that you downloaded from a website, you can pull the code, compile it yourself, and you should get exactly the same binary file. Yep. And this is not true at the moment for, say, 99% of the code out there. If you try to compile the Linux kernel, and don't quote me on this, I may be wrong, but my experience is that if you compile the Linux kernel, even with the same config file, with the same flags passed to the compiler onto different machines, they will differ. It might not be by much, but the final binary blobs will not be the exact same. And
yeah, there's all kinds of things that go in.
Don't quote me on the Linux kernel. I'm not exactly sure if they don't already include some reproducible build information on their make files, but most projects out there do not. And again, this causes issues if you're looking for security problems, because you won't be able to compare 2 systems and see what binary files were changed, for example.
Yeah, and I think if we had this, it would actually give end users more control too, because we're not always going to look at things, but there's some of us out there, and I love these people. They will do packet captures with the traffic going in and out of their network card, and they obviously there's going to be a lot of noise there, but if they notice that this certain IP is being hit, and they can compile that same package on another distribution or another system and see if they get the same problem. Okay, their binaries are different. One is contacting an IP address. Okay, there's definitely a problem with that one that's not present when it's compiled. It's from the actual source from a reproducible build. Then that's just even more proof, as if you even needed more proof that there's something going on here. And even if you didn't see it connect to an IP, if you have any doubts at all, you would have the peace of mind that, yeah, maybe you don't know like how to go through all the source code, but you could run some commands to compile it. Do you get the same thing? It's good to know.
And say if you have a Linux installation, and instead of installing a specific package from the repository that you have with the system, you compile the source, you'll notice that you will not get the same binary file. It won't even be the same file size.
Right.
One will be probably much larger than the other because different flags or something like that were used. And even to create a security tool that checks the binary files to see if someone has tampered with them, they would flag that thing that you compiled on your own. There would be nothing wrong with it. You just decided to compile it from source yourself, and it would be flagged as something that, this might be a problem, and it wasn't. So having reproducible builds everywhere, it would even help with that. And that's something that's suggested heavily on the SLSA specs.
Yeah, I remember Debian was working on that. I have to kind of refresh myself with where they were. I thought I read that they have it already or they're making progress on it, but maybe I'll follow up on that part.
Last I checked, the Debian BSD was pretty ahead on it, but they didn't have every package still. They had like something like 60% or something that were already under reproducible builds specs, but not all of them.
One of the things that I love about Debian, I know other distributions do this as well. Like some people get upset when they go to install a package on, Debian 7 it was on Debian 7 and now they're on Debian 8 and they can't install that package. Why is that package not there? Well, because it's abandoned. It hasn't seen any commits in a bunch of years. We're not going to include it in our distribution. So I think that's a great thing that they do as well, is they just sunset these unmaintained packages. Sometimes it frustrates people, but that's how it goes.
It's funny that you mentioned that. One of the ways that you can attack the supply chain, for example, is if you find a code repository that has been abandoned and you contact the author and say, hey, I'm really interested in this and I see you haven't maintained it in years. Can I take over?
Wow.
And the guy, yeah, I have no interest in the project. I'm not even using it anymore. Sure, here are the keys. Go right ahead.
I think I've seen in several crime movies where they say the best place to hide is right out in the open. And I think that's exactly what that is. They're not just secretly downloading the repository, hacking the server, and no, hey, can I help with that? Yeah. I'd love to work on that. Mm-hmm.
I'm really interested in that. Can I help?
Sure. Yeah, can I help you? Not the help they were thinking they were going to get.
Yeah. Let me just make these 10 commits that somehow change that file upload thing there a bit and just send a copy to my server as well.
Wow. Yeah, that is just crazy. Just it's clever in its simplicity. Hey, can I help you? Yeah. Sure.
Social engineering at its best.
Absolutely. That's I think that's a topic we're going to be talking about quite often. Social engineering is definitely going to be a recurring thread throughout this entire podcast. Absolutely.
Many of these issues will be recurring.
Yeah.
Supply chain attacks will not go anywhere. SolarWinds, it got all the news that it did because it was so far-reaching, and it originated in a supply chain attack. Somebody tampered with the build server where SolarWinds was creating their packages and got malicious code in there with whatever they were trying to build. And that got distributed around, and major companies got it, and it started like this. It started with a supply chain attack.
Yep. I also feel like the enterprise employees, they just need to drop the everything is fine mentality, which is not every company's like this, but maybe I've just worked for a few not so great ones, but it's just the mentality at one company, for example, was, just download a Docker container. Someone's already wrote it. Just download this, just download that, just download, why? And I'm like, are you checking these?
Yeah.
I mean, are you looking at these things? Do you know the history? And then they look at me like, why would you care? It's a Docker container and you just download it and it's less work. I'm like, really? Mm-hmm. This is not going to go well. This, at some point, that mentality will get you every single time. Maybe not today, maybe not tomorrow, but eventually you're going to download something that has been a victim of a supply chain incident and it's going to be on your servers.
Absolutely. And sometimes it's just companies don't have the staff. Companies don't have the resources. They don't have the people with the right know-how to do that.
That's true.
Sorry for the redundancy. But yeah, having this standard, that will actually help, because now it's possible to create tools that check the bill of materials to see if whatever is inside that Docker image actually follows the right library versions and everything like they say they do.
Yep.
So it's another step in the right direction even for that.
So I'm going to definitely include links to SPDX, SLSA, as well as the University of Minnesota video that we did, because that, I mean, hearing that, I think will kind of further drive it home. Even though that was a botched experiment, it still kind of works here because they were able to do it. So if they're able to do it, other people are able to do it too. So I think it'll really help to understand the full scope of this, because if you're responsible for developing software or you're within that realm, I think it's definitely something everyone should know about. And that's how it gets started. You get the conversation started at your place of employment with your peers. Here's SPDX, what do you think? And here's SLSA, and get the conversation started, because you could definitely get things going in the right direction.
Yeah, absolutely agree with you. Sometimes it might seem like we are doomsayers here and we're just pointing out the bad points and all that. But the thing is, security in the IT space, let's just say it's a bit leaky. It's not as tight as it should be, and it has a lot of improvements to do. And we just want to point them out so that people can be aware of them and strive to get better at what they are securing.
Yeah, absolutely.
Because in the end, if you secure your servers better, they won't be compromised. They won't be attacking anybody else's servers. And it helps everybody if you protect your servers better. So it's in everybody's best interest that a specific company's security is improved. So even if your own security is top-notch, if the other one right next to you is not, they will be compromised and their servers will start DOSing yours, and you'll be harmed as well. So this needs to improve security-wide. It's not just something that can happen at one organization or another or individual level or something like that. And that's why standards are important here, and why this news is actually very, very important.
Yeah, I mean, essentially, we're trying to help people have their companies not be on the news for the wrong reason. Be on the news because your company's great and you're doing something amazing, and people need to talk about it, not because you've been pwned and inside out and you're out of business. But you're right; it's not about scaring people. I think it's about education. It's about learning what can happen, so that way you could better identify the signs that something not so great could be going on, so that you could identify that quicker. Hopefully, just prevent it from happening in the first place, but at least understand the realm, the world just that you're in with development, what can happen, what to look for, what are the best practices here. And it's not to be overwhelming. I know developers are so stressed out because they're so busy, but it's just keeping your eyes open, learning about the things that can happen, educating yourself and your peers. And I think having conversations and learning is the way to fix this.
Absolutely. Awareness, increasing awareness and information out there, it can only help.
Yep. And we'll do our best to educate you guys with every single episode of this podcast. We'll let you know some of the things that could happen. And I'm sure it's only a matter of time, that goes without saying, that we're going to have plans for a specific episode that we have to put aside because there's been a big security event and we need to talk about it. How did it happen? What were the lessons that could have been learned? And those episodes paired with these ones, I think, are going to definitely help some people out.
Yeah, hope so. All
right. Well, I think that's everything on our list. So definitely read the links that I'll have in the show notes. Wherever you're getting this content from, you should find the links there. If not, just go to enterpriselinuxsecurity.show. You'll find the information there as well. As always, I'm Jay.
I'm Joao.
And thanks for listening.
Thank you, guys.